Today we're running another experiment from the video series we planned for the workshop. What you're seeing here is an old power supply that we no longer use, and we're using it to run a simple but very important test. The goal of this experiment is to measure the conductivity of different liquids that are commonly used near or even inside a computer. A lot of people assume that some of these liquids are completely safe, but today, we're going to test that assumption. Let's start with something very popular: liquids used in custom liquid cooling systems. Here we have 3 different brands, and we're going to test each one. First, we pour a small amount of Corsair coolant, the green one, into our test area. Next, we do the same with EK. And finally, a bit of PrimoChill. Now, these liquids are marketed as non-conductive or low conductivity. That's why many people feel comfortable using them inside their systems. But instead of trusting the label, we're going to measure it ourselves. Here's how the test works. We have a 4-volt power source connected, and we're using a multimeter to check whether current can pass from one probe to the other through the liquid. If we see voltage on the meter, that means the liquid is conducting electricity. We clean the probes, dip them into the first liquid, and there it is. We are getting conductivity. Now, we repeat the same process with the EK coolant. Again, we see voltage passing through. And finally, the PrimoChill liquid. Same result. There is conductivity. Now, it's important to mention that we are not getting the full 4 volts. The voltage drops, which means resistance is present. But the key takeaway is this: current is still flowing. And that's what matters. So, what does this mean? It means that if any of these liquids spill onto a powered motherboard or any energized component, there is a real risk of damage. Now let's move on to something else. This is a product called SuperFlush. It's commonly used to clean liquid cooling systems without fully disassembling them. You run it through the loop to remove impurities and leftover dye. We test it the same way. And as you can see, it also conducts electricity. So again, this is not something you want spilling onto your components while your system is on. Now let's go more basic. Distilled water. Many people believe distilled water doesn't conduct electricity, or that it's completely safe. Let's test it. We dip the probes. And yes, there is some conductivity. Not a lot, but it's definitely there. Now for another common assumption. Isopropyl alcohol, 99%. A lot of people say alcohol doesn't conduct electricity. So let's find out. We pour a small amount, place the probes, and we do get conductivity. It's lower than water, but it's not zero. And just to be clear, this is real alcohol. You can even see how quickly it evaporates compared to water. So again, it's safer in some contexts, especially for cleaning. But it's not completely non-conductive. Finally, let's test something different. WD-40. We spray a bit, clean the probes, and measure. And here, the conductivity is extremely low. Almost none. So at first glance, you might think this makes it safe. But there's a catch. WD-40 leaves a residue, a thin, insulating layer on surfaces. If you apply it to something like RAM or memory slots, it can interfere with proper electrical contact. And that means your components might stop working correctly unless you fully clean off that layer. So even when something doesn't conduct electricity, it can still cause problems. And that's the main lesson here. When it comes to electronics, especially powered systems, any liquid can be risky. Some conduct more than others. Some leave residue. Some behave differently over time. But none of them are completely harmless. So, always be careful. Avoid spills. And never assume a liquid is safe just because it's labeled that way. We'll keep testing more liquids as we go, and continue showing you which ones conduct, which ones don't, and which ones can potentially damage your computer.